Today we're going to be changing the way dark mode animations work on the web. So check this out. Most dark mode toggle animations on the web are just color fades. So the color fades from black to white and vice versa, right? This is pretty much how all dark mode animations work across the web, operating systems, pretty much anywhere. But I wanted to have something different. I wanted to have something unique compared to everything else that is out there on the web. So I came up with this thing. Okay, so we're going to be implementing this thing basically, and I'm going to be going through what I had to do to make this thing work across all devices out there. So this is an Android emulator, and well, it's going to be working on this thing, and it's also going to be working on my iPhone in here. So it's going to look like that on an iPhone. I would say the most difficult part of getting this animation right is adjusting it to different devices and different screen sizes, and it has to work on everything, right? It should work on different screen zoom ratios, whatever those things are called. It should work on landscape mode. It should work in a web view maybe. There are many things that can go wrong in this animation. I've pretty much spent the last month trying to fix everything. It's been quite difficult, but I managed to do it at the end. So yeah, let's get into it. Okay, so currently we have this fade animation, and the way I have achieved the other animation is by just using a canvas. I've written a full blog post about this, and it talks about most of the decisions that I made while making this animation. So this YouTube video is meant to be like the introduction to this blog post, and then once you finish watching this YouTube video, I strongly suggest you to take a look at this blog post and fully read it, understand it if you want to implement something similar or maybe the same thing for your website. Okay, let's dive deep into the code now. So this is my blog component, and this is my blog post component, and I pretty much achieved the dark mode and the light mode color shifts with CSS. So let's go into blog post module.sass, and in here I think I have background color set to white in blog post background, and in blog post dark I have background color set to midnight black, and then I apply a transition for background color, and yeah, that's pretty much it. This is how you do a fade animation. It's dead simple, but the animation that we're going to do today is obviously extremely complex compared to this thing. So yeah, buckle up and let's start writing a canvas component now. Okay, so I'm going to create a new component in here. Let's create a new JavaScript file, and let's call this growing circle animation.jsx. Now that we've created the file in here, I'm going to go and refer back to my blog post. So let's go here and scroll down until we see the first code snippet in here. And I'm going to literally copy this part and paste it in here. This component that I have is called circle canvas, so I'll just rename it to growing circle animation. That's fine. So let's go through what this thing does. It imports React, and it uses two hooks from the React library. The first one is called useRef. So useRef allows you to refer back to an element that you're returning back from your component. So in this case, we need a reference to this canvas. That reference is going to allow us to refer that canvas from JavaScript code, and we're going to put some stuff in the context of that canvas so that canvas can start drawing. So in the useEffect hook, I'm going to refer to that canvas component by just saying canvasref.current. That's going to give me the canvas in here, and I'm going to call the getContext method, and I'm going to use argument 2D because we're going to be drawing a circle, not a sphere. We will be working on a 2D context. And the first thing that you want to do when you get your context is you want to clear the rectangle. Like that means empty everything that you have in the canvas, and then you set the fill style, which is the color that you're going to draw your objects with. And then you start drawing something by calling the begin path method, and then context.arc. This allows you to draw arcs. And in here, if you specify 2 times math pi, that's the circumference of a circle, and this allows us to draw a circle with a radius 60, and it's going to be 75 pixels away from the left and 75 pixels away from the top. And then context.fill means we're going to fill inside this path that we have, and window.requestAnimationFrame tells the browser to draw what we have in the context so far. Okay, so now that we have this component, I'm going to refer back to this thing in my blog. So the best place to put it in our blog would be right after our meta decorator. So we're going to put this inside the main div, which is like, it should be sitting on top of the page really. So let's refer back to it, growing circle animation. So we have this thing in here. Let's go back to the website and check how that looks. All right. So we have a circle right here, which is like a blue circle. Up next, we're gonna start drawing a circle that grows, if that makes sense. And then up next, we have another code snippet in here, and this one draws a growing circle. So I'm gonna come back here, replace the contents of that one, and let's replace this with growing circle animation. Let's go through this code. So we have similar stuff in here, right? We are referring back to the canvas. We are drawing some stuff in the context again. But different from the previous one, we have the frame count and animation frame ID in here. Okay, so the frame count starts from 0 and animation frame ID, I'm going to talk about it in a bit. So in each render, we're going to be increasing our frame count by 0.5%, and I've just realized it's a very bad idea to call this frame count. Let's just call this radius. Okay, so each time the render function is called, we're going to be increasing the radius by 0.05%, and we're going to be calling the draw function in here, and then we're going to be requesting an animation frame, which makes the browser draw what we have in the context so far. And as soon as that render completes, it's going to call back the render function again. So window.request animation frame takes a callback in here, and it calls whatever you put in there. And if you refer back to the render function, then it's going to call this render function again, execute everything, draw another frame, and then call render again, and then it will keep doing that. Okay, let's see the draw function, and let's see what this thing does. So it clears the rectangle, clears what we have in the canvas so far, sets the fill style to white, and actually I'll just set this thing to blue for now. Okay, let's keep drawing a blue circle. It does the same thing, but instead of a fixed radius, this time you're going to give it a dynamic radius. And remember, this thing is increasing constantly, right? And once we are unmounting the components, we're going to cancel the animation frame. So cancel animation frame cancels the animation frame that we were drawing, and that's where we use the animation ID, animation frame ID. So if this component ever gets unmounted in its life cycle, it's not going to keep drawing anymore. It's just going to cancel drawing, and that's going to be the end. It's not going to be consuming any more of your CPU cycles. Okay, let's see how this thing looks. Okay, so as you can see, there's a circle that starts growing. Actually, maybe you have noticed it looks kind of pixelated, right? I'm not sure if it will be visible on your screen, but if you're trying this on your machine, then you're going to see that it looks kind of pixelated. And it started running out of bounds of this canvas component height that we have in here. But yeah, the circle is growing and the render function is being called. So this is how you start a growing circle animation. So now that we have this, we still need to figure out a way to link this thing back to this dark mode toggle that we have in here, right? So when we click on this thing, we want the circle to start drawing. We don't want to start drawing the circle as soon as we land on the page, right? Because that doesn't really make sense. We want to transition into dark mode as soon as the user clicks this dark mode toggle animation. The next step is to create our custom events. So I have to link this thing to the dark mode toggle button, which is here, and this canvas needs to have some sort of event listener, and when I click on this button, it needs to fire an event, and then that event is going to get called by this canvas component in here. How do we achieve that? Well, we can use something called custom events. So let's go into dark mode toggle, and here we have very simple stuff. So there's a button, and then if you click to that button, then it changes the state from is dark to not is dark, which means like you're switching between dark mode and light mode. We're gonna kind of do something a bit more complicated in here. So we have an on-click wrapper in there, but we're gonna be creating a new custom event. Constant dark mode toggle event equals new custom event. And we're gonna call this event dark mode toggle, and then before we close that, we're gonna give this thing some arguments. If you don't know what events are, events can be mouse clicks, resizes, and you can have an event listener on your website that listens to resizes, clicks, mouse scroll events. There are lots of events that you can listen to. Okay, now that we have this, we're gonna add some arguments in here. So event detail carries all the arguments that you might want to put in the event, and then when you send this event, you want to send an event with some arguments, and these arguments can have things like mouse coordinates, strings, or whatever you want to put in them. So you're sending an object from one component to another component, and you can package in whatever you want inside this custom event and then pass it to another component that you might have in your component tree, I guess. All right, so we have created an event now, and we have to emit this event somehow. So we're going to dispatch this event. Each time dark mode toggle is clicked, we're going to start drawing the circle. And now we're going to catch this event in the growing circle animation. And I'm going to add the listener in here now. So window.add event listener. So we're going to call this dark mode toggle. That was the name from the previous one. And we're going to call a method. Let's just say we're going to call handle click. That method doesn't exist yet. We're going to make that. So, and when your component unmounts, you want to remove your event listener, toggle, and the same function goes here, handle click. Okay, let's create the handle click function. It's going to take the event itself. Let's just put a variable in here. Val should draw, I shouldn't use val, I should use let. Should draw start with false. And we click on the thing, it should start drawing. In here, we're going to have if should draw, then call the render function. So what does this do? As the event listener, and when we receive an event, it's going to call the handle click function. That's going to set this variable to true. And when this component re-renders, I mean, change between dark mode and light mode, the blog component, this component re-renders, right? Because it's a state in here. A state change triggers a re-render of the component, and this thing is going to get re-rendered. And we need to use a global variable in here so that it doesn't get erased when this component re-renders. I'm not sure if that's the best practice, but we're going to utilize that a lot for this component because I found that to be the easiest way so far. Okay, let's try this out. So nothing is drawing right now, and I'm going to click this, and a circle starts growing now. Okay, up next, we're going to add some style to this circle component in here so that it starts taking the whole background of the page. And I have written some CSS for that. So we're going to be using the canvas as the page background now. Okay, so we're going to create a Sass file for this thing. All right, so let's go into style sheets, new file, going circle animation.module.sass. And let's paste what I had in my blog post. So it's going to take 100% of the page width, 100% of the page height. Position is going to be fixed because we don't want this to scroll around with the rest of the page. Set index -1 means it's going to sit at the back of everything else that we have in the blog. The background is going to be 111, which means if there's no circle, the background of the canvas should be dark mode basically. That will make sense hopefully shortly. Okay, now let's import that in here. Animations, go circle. That works, and we're going to copy this and refer to this here, class name, and paste it in there. Okay, now the circle should take the whole background of the page, hopefully. Okay, so we should see a circle drawing somewhere. All right, the reason why we can't see it is because we haven't set the background of the blog page to be transparent. So remember, it's sitting at the back of everything right now. And if the background of the blog is switching between white and midnight black, then it's going to be sitting on top of our canvas component, which is at z index -1. So let's go into blog.module.sass and let's remove this background style. And we're going to remove this one. Okay, so as soon as I click this, a circle starts drawing, and now you can see it is a lot more pixelated, right? This is because we haven't set the scaling factor of the canvas. This is drawing at a very low resolution at the moment. Anyway, before we do this, this is drawing super slowly, and from now on, I just want the circle to be drawing faster, so I'll just modify the speed. And let's just grow 10 times faster now. All right, so circle is growing. It's going to take the whole background of the page. And just like that, we have an animation. So now let's take care of the pixelated nature of this thing. I want to assign some good resolution to this. It looks super pixelated on this screen. Let's refer back to the blog post. Somewhere in here, I have the code that's required for scaling. So if you copy this thing and then paste it in here, it's going to scale the canvas automatically depending on what size you've assigned to your canvas. It's not going to look pixelated anymore. As you can see, the corners are super sharp, and so let me increase the growing speed once more. So radius is going to increase 10 times faster now. So when I click, you can see it's taking the whole background of the page. You pretty much got the idea of what we're trying to do in here, right? Next thing we need to do is to set the center coordinates of the circle to be the dark mode toggle button, just like what I have in here. Remember when I was talking about the dark mode toggle, I said you can pass arguments into this custom event that you have here. You're going to pass the coordinates of the dark mode toggle in here, and that's going to be used in the canvas, and we're going to set that as the center coordinates. Okay, time to refer back to the blog post again. Okay, so I have this code selected in here. Let me just copy and paste everything and it will make a lot of sense. You're going to get the bounding rectangle of the document, we're going to get the mouse coordinates of the event. This offset left, element rectangle left minus body rectangle left gives us the offset from the left of the dark mode toggle, which gives us the relative x coordinates of the dark mode toggle. And element rectangle dot width divided by 2 in here gives us the center point of the dark mode toggle. Now that custom event state is containing the mouse coordinates, we can go back to the growing circle animation and we can define another variable in here, I assume. Let's do, I don't know, mouse x. Let's just do null for now. Mouse y equals null. Okay, so as soon as we receive this event in the handle click function, we can now refer back to the actual mouse coordinates. So let's do that. So mouse coordinates dot mouse x is going to be event dot target. It's not going to be event target. It's going to be event dot detail dot x. Mouse coordinates mouse y equals event dot detail dot y. So this is going to add the mouse coordinates there, and we need to set the x and y coordinates of the arc to be mouse coordinates dot mouse x, and that's going to be mouse coordinates dot mouse y. Okay, let's go back and try to see if this works. So when I click on the dark mode, the circle center should hopefully be this dark mode toggle, and as you can see, the circle has started growing from the center of the dark mode toggle now. Okay, this works now, but we need to work this across different platforms and different browsers, and also the circle needs to retract when I click this thing, and we need to somehow link this with the dark mode toggle and the dark mode state itself, right? Okay, to do that, we have to come up with a very complex structure. Not really complex, but manageable structure. Because if you take a look at this, this is looking pretty bad already, right? It's just drawing a growing circle, but the code is like literally everywhere. If I come back to this next year, I would probably not be able to understand this. So that's when I decided to come up with a state machine. But before we talk about the state machine, there's one little detail that I want to share with you. So the laptop that I'm working on right now is a 2019 16-inch MacBook Pro, which is super nice, but I've also tried this on a slow smartphone and also a laptop from 2006. If you run this animation code on a MacBook Pro, the animation pretty much looks like this. The circle grows super fast, but if you run this code on a slow laptop, then the circle grows slowly. This is because slow CPUs and slow GPUs, they can't render everything super fast, and I'm currently increasing the radius by 5 as fast as the CPU can render. So I'm using the maximum capacity of a single core on my system here. But if you have a slow single core score, then you're probably going to have decreased performance and it's going to just draw slowly. One thing that game developers use is they base animation off of time. Game developers, when you're playing a game, if you don't have a super fast computer, your frame rate is going to be worse, right? Animations are going to skip from time to time. Like you're going to have some hiccups, but at the end of the day, the physics and everything else is going to play out the same. So what we want to achieve is, I don't want the animation to take forever on a slow laptop. I just want it to skip a few frames, like literally like a game does. The circle should still be growing at the same rate independently of your CPU speed. So I've talked about how we achieve that behavior in my blog post in here. I'm not going to talk about how I implement that part yet, but the code is here and I pretty much explain this part in my blog post. So if you're interested in how we did that, then you can refer back to this blog post. So up next, I want to talk about the more complicated part of this animation. We want to make this animation look nicer, right? This animation is currently drawing a circle that grows linearly. So when you click on this dark mode toggle, the circle is growing at a constant rate and it's always at the same speed. But if you take a look at the finished product, the animation looks a lot more exciting because it grows exponentially. Let's refer back to the blog post again. I tied the growth of the circle to this exponential function in here. At first, it starts growing out slowly and then it starts getting faster and faster as the circle expands. So this is how it looks linearly. And then this is the exponential growth version. We can do that by tying the radius of the circle to an exponential function. We're increasing the radius by 5 in here, right? And we're applying the same radius in here. So rather than applying the same radius in here, we can do something like this. We can use mat.power and then radius to the power of 2.9. Okay, it says use the exponentiation operator instead, but that's okay. We can change it later. And if we increase radius by 5, and if we also use math.power in here, we're going to end up with a circle that grows insanely fast. You'll see. See, it's growing super fast, and we don't want that. So I'm going to increase the radius a lot slower in here. So hopefully you can see it in effect. All right, it starts growing out slowly, and it gets faster and faster as time passes. So this is exactly the same thing that I have done in the finished product in here. Okay, so we need to do all of these things in a very structured way. And this code, as I said before, is getting very complicated, and if I come back and take a look at this next year, I'm not going to understand any bits of it. So I'm going to structure this in a way that is going to be understandable even 5 years later. So I've decided to use a state machine. When we land on the component, we're going to call the create machine method, and then it's going to call another method in itself, and then that's going to call another method, and then it's going to verify if we're still within bounds, if we shrink the circle, and then it's going to keep doing the same thing over and over and over again until we decide to stop the animation. Okay, one thing we haven't discussed so far is how we stop the animation. So right now we start animating, but then the circle keeps growing and growing and growing, and it never stops, and it never retracts back. Well, we can pretty much do that by getting the maximum radius possible for this screen size or for any possible screen size. Well, there are two things that we need to know before we stop the animation. So the circle is growing, but then we need to stop this animation as soon as the circle hits the bounds of the screen, because otherwise we're going to keep drawing the circle and it's going to get bigger and bigger and bigger and bigger. To stop the animation, we need to know what the maximum radius of the circle can be, because there's no point in drawing a bigger circle if this circle is already bigger than the screen itself, right? And also, if you're doing a retraction, like imagine if you're playing this animation in reverse, just like this one. So the circle is getting smaller in this case, right? If the circle is getting smaller, then we need to stop this animation when radius hits 0, and we need to stop the growing animation when the circle itself gets bigger than the page. So that's what we do in here. So we get the screen height and the screen width, and we set a maximum radius multiplier by dividing the maximum screen width or maximum screen height by the growth function exponential. We were using an exponential function to grow the circle, right? And that was x to the power 2.9. This is an arbitrary value that I think looks nice when you're animating your circle. So we can reverse this function and use that to calculate what the maximum radius multiplier can be. So in this case, our radius multiplier is increasing by 0.05. I'm using exponential function power to 2.9, and we can have a check inside our render function in here. So we can say something like if radius is greater than max radius multiplier, then well, we're going to do that. If radius is smaller than maximum radius multiplier, then keep calling these things. But then if it's not smaller than the radius multiplier, then there's no point in calling the request animation frame anymore, because there's no point in drawing a circle anymore. So to calculate the max radius multiplier, we can, well, import what I had in the blog post before. So let's copy and paste all of these things. Why not? So I have the copy button in here that I've added in one of my previous streams. So let's just paste these things here. So we have the screen height and the screen width, and the maximum radius multiplier is going to be the growth function exponential that we have, and that is 2.9 right now. So this is going to give us the maximum radius multiplier. If radius is smaller than maximum radius multiplier, then we're going to keep drawing, but as soon as the radius hits maximum radius multiplier, then there's no point in growing the circle anymore. All right. Let me just do console.log current radius, and this should stop printing as soon as the circle hits the boundaries of the page. Let's do inspect elements on this page and console. Just click here, and as you can see, the radius is growing and growing and growing and growing, and it stopped. We didn't hit the boundaries of the screen, but we can fix that by just making the radius multiplier slightly bigger. But as you can see, the circle stopped growing now. So next thing, we're going to talk about the structure of this code. We can use state machines when we're designing animations, right? I've come up with a state machine diagram in here. We're going to create the machine, we're going to start the machine, and depending on if dark mode is enabled or disabled, we're going to shrink the circle, we're going to grow the circle. If the circle is still within bounds, which means the radius is not 0, or the radius is still within the maximum radius multiplier that we've just defined here, then we're going to draw the circle and then go back to the start state, and then keep doing this until the circle is out of bounds, which means we're going to go to the end state. But how do we implement a state machine in JavaScript? Well, to do that, we can use an object. We can represent a state machine with an object in JavaScript. We're going to have each of these states as variables in an object or fields in an object, and each one of these fields is going to be a function itself. And each state is going to return the next state as a function. So grow circle is going to return verify circle bounds, and something has to call this, right? We will have a state machine runner. So this thing is going to create a state machine, and this is going to return a function. This variable is going to be a function, and we're going to have a state machine runner function here. And we might be getting into super complicated territory, but bear with me. It will all be clear hopefully very soon. And the state machine runner function is going to start with if state machine is not null, which it shouldn't be because we've just created a state machine, and the create machine function will return the start function. So this thing is a function right now, and we're going to call that function and we're going to assign it back to itself. So if we call state machine, this is going to return the start function. And if you call the start function, then it's going to return us either shrink circle or grow circle, depending on if you're in dark mode or light mode. Okay, and when we're in shrink circle, we're going to shrink the circle, and then after that we're going to verify the circle bounds. If circle is outside of bounds, which means if you're above maximum radius multiplier of the, or if you're shrinking the circle, if your radius is 0, then we're going to return null. And if we return null, then that means our state machine is going to terminate. That's pretty much it. This is super simply explained state machine stuff. This might come quite complicated at the beginning, but if you really try to understand it, it just adds a lot of structure to your code and it makes it extremely readable compared to what you had before. So at this stage, I'm pretty much going to scrap all of this and start implementing the state machine version of this. But this video is long enough already and it covers most of the major details. So I'm going to save the state machine implementation to the second video. And I hope you learned something new. I'll see you on the next one. Bye. I don't know, there's something with this animation that makes you want to play with it. Huh.